The planning experiment question. A student investigates the effect of a double-walled insulation. This type of question we did. So, okay, question 14, planning experiment. The question is, a student is investigating whether the distance that a toy truck travel along a horizontal floor before stopping depends on its mass. So that is a an experiment. Like student is investigating how much the distance traveled by a toy truck depends on its mass. The following apparatus is available. A ramp is there. A block to support the ramp is shown in figure 4.1. You can see the blocks are there supporting the ramp. A toy truck is there, a selection of the masses and other standard apparatus for the physics lab. What we have to do, we have to plan an experiment to investigate whether the distance that the toy truck will travel along the horizontal floor before stopping depends on its mass. In your plan, you should explain how would you carry out the investigation and then state the apparatus that you would use that is not included in the list, the key variables that you would control, and draw a table or the tables with a column heading to how you present or display your result. So anyone want to add on how we will perform this? The experiment. So first of all, you can use your mic, you can use chat or screen annotation to answer. No need to mention the speed here. Like we don't have to measure the speed. We have the experiment is what? Look, what is the experiment, the core experiment that we are investigating how the mass of a toy truck depends on the distance moved by the toy truck. Like example, we release a toy truck with a certain or a known mass, and it travel a horizontal distance on the floor. So we are investigating how this distance traveled by the toy truck depends on the mass of the toy truck. That is the main core experiment. Okay. So that is the main experiment what we want to. So first, whenever you mention try to answer the bullet point. Explain how would you carry out the investigation? What we should do in this investigation? What could be done in the experiment? Anyone want to add on?
Sir, as soon as we release the truck,
Okay.
as soon as we truck from the ramp, at the start
Okay.
of the ramp, we will start the stopwatch. And after starting the stopwatch, we will note the time final. We will record the initial time and the final time. After that, we will repeat this experiment for different trucks with different masses.
Okay, but the question is, you mentioned a stopwatch, but we don't need a time here. Why we don't need a time? Because we want to investigate how much distance the toy truck travel on the horizontal. Like once we release, you're right, we'll release a toy truck from the ramp, and once it goes, it will stop on the horizontal. So what we need a meter rule here. So only thing add on in your experiment, instead of mentioning So instead of mentioning about the distance, like the speed, what you will do, how you carry out this investigation. So we will place the toy truck with known mass on the ramp. Then we will release the then we'll release the toy truck from the top of ramp, and we allow it to stop, and we'll measure the distance moved by the toy truck on the horizontal surface. So that is our experiment. We place a toy truck with a known mass on the ramp, and we release the toy truck from the top of the ramp. So we release the toy truck from here. We don't need a time here. Why we don't need a time? Because we don't want to measure the speed. So when we release, the toy truck will move and it will stop at a certain distance horizontally. So using a measuring meter rule, we'll measure the distance moved by the toy truck. Then we will repeat the experiment with different masses. So we'll do the experiment, or we'll repeat the experiment with different mass of the toy truck. But you are not supposed to say repeat like only single time. You have to mention how many times you will repeat. So repeat experiment with 5 different masses. And then what you should do, whenever you are writing any like investigation or the procedure, you should mention the source of error or the uncertainty. So what we should do, we should avoid a parallax error in measurement of the distance. Even though they did not ask us to write, but whenever you're writing an investigation, always include the source of error or the uncertainty in the results. Not zero error here. Here we don't have any zero error, as one of the student mentioned, because we are not using a stopwatch, so there is no zero error. Avoid a parallax error in the measurement of a distance, or avoid pushing the toy truck on the ramp. So even though they did not mention that write the sources of error or the precaution, but whenever they ask us, you have to write the source of error and the precaution in the explanation, investigation. Is it clear? The first part? Anyone having a doubt? How we did this? So what we did, we take a toy truck with a known mass and we release from the top of the ramp, and we measure a distance moved by this toy truck to stop. Then we repeat the experiment with different masses, 5 different masses of the toy truck, and measure a distance it takes to stop. Yeah, we need a meter rule. That's right. We need a meter rule to measure a distance. That's right. But we don't need a stopwatch. The next is state an apparatus that you would use that is not included in the list above. So in the list above, what are the apparatus which were listed above? No need for odometer for speed. You need meter rule. No need for, you need a meter rule for to measure the distance. No, you use a ruler to measure the distance. We don't, we can use a protractor if you mention protractor, like to make sure that the angle is same. So protractor is one of them, but the most important thing, because if you see, we are investigating whether a distance, so we have to measure how a distance depends on the mass of the toy truck. So there is no apparatus listed here which is measuring a distance. So the most important apparatus which you should mention here, it's a, so the most important apparatus which we should mention here, it should be a meter rule or a meter scale. State the key variables that you would control.
Sir, the angle of the ramp and where we release the toy truck
Angle of
and
mass of the
like
toy, the mass should not be constant. Angle of the ramp, yes, that is right, Ayan. Height of the ramp from the floor or the,
and the truck is same you use.
we are investigating, the main experiment is how the mass is affecting the distance. That is a main experiment. So we are not supposed to change the angle. So same number of the blocks should be used. That's right. Starting position of the truck, that's also correct. But you cannot say the mass. Why you cannot say the mass? Because we are investigating how the mass affect the distance traveled by the truck. That is the investigation. If you keep the mass same, it means how you can change the, how you can find the effect of the mass. Use the same type of the truck, same shape of the truck. That is right. That is also another thing. Appropriate is the number of the blocks which you use for the ramp or the inclination or angle of the ramp to the horizontal surface. The position where you release the truck, that should be same. Like every time you should release from the same point. So if you mention, yes, if you mention the number of the block or the angle, it's the same thing. Any one of them, as I mentioned, any one, either you mention a block or you mention the angle. For a friction, you can mention the type of the ramp. If you want to lead or refer a friction, so the material from which the ramp is made up of, or the truck, the tires or the wheels of the truck, the toy trucks are made up of, that material should also be same. Then draw a table or tables with a column heading. What should be the table? Because we are investigating how the mass can affect even though SI unit of the mass is kilogram, but in the lab, the common one which we are using in gram. Same thing, SI unit of the length or a distance is meter, but in the lab we are using centimeters. So the appropriate units table is always with a column heading. So like if you wrote a mass, it should be slash gram. If you wrote a distance slash centimeter. So in the lab, we are using the, not using the SI units, like example, kilogram, meters, because in the lab we have a short distances. So it's advisable that use grams and centimeters to represent the column heading. If you write a unit in kilogram, you will not lose a mark. You will not lose a mark if you write a kilogram or a meter. But I'm saying practically we use a gram and centimeters and millimeters rather than a meter in the lab. The scale is short, that's why. We are not supposed to mention anything related to speed because we are investigating how the distance traveled by the toy truck depends on the mass of the toy truck when it is released from the top of the ramp. No, distance is speed multiplied by time, but we are not measuring a speed and the time. What we are doing, it's a measurement rather than, look, if you measure first speed and then you calculate a time and multiply, this will have greater uncertainty as compared to you directly measure a distance traveled by it. Okay. Is it clear to everyone? This experiment? How is the calculation having more errors than because look, when you're calculating a speed, how you're calculating a speed? You are using you have to get the speed, you need a distance and time. So there's an uncertainty in the measurement of a distance and there's an uncertainty in the measurement of a time. So the total uncertainty in the speed will be the sum of uncertainty in distance and time. But if I'm directly measuring it, I will have a low uncertainty, like a single measurement. The last point is only about the table. So what table we need? We need, because we are investigating how the mass affects the distance travel. So m slash g and the distance slash centimeter. But if you write a kilogram or meter, that is fine. You will not lose a mark, but the lab, as I mentioned, we use preferable units of a length are centimeters and meters, and for mass is kilogram. Do we write the whole word in heading? You can use a symbol. If you write a word, that is fine. If you write a symbol like mass, you write M instead of writing it full, you will also score the mark. This is a answer from the marking scheme. So method include like we place a truck. Yeah, the change is, no, they did not change it. They keep it same. This is a control variable. Control variable means which is not changed, which kept same throughout the experiment. You're not supposed to say which variable is dependent and which is independent. So we place a truck on the ramp and we release. We measure a distance from the bottom of the ramp and then we repeat with different masses. We use a meter rule or a measuring tape is needed. Height or angle or a number of supports that should be same. A position or the height from which we are releasing it. And table with a column heading the mass and a distance travel with the appropriate units. So appropriate unit, they did not say SI unit, they say appropriate unit. That's why I'm saying practically gram and centimeters are more appropriate for a mass and length as compared to kilogram and meter. Is it clear, this experiment? Anyone having a doubt?